Hi, welcome to Mathematics with Tom. This is Tom, and today what we are going to do is we are going to continue our exploration into the logistic equation. Now, let's take this another step. So here's the general form of the logistic equation. So the general form is y prime equals a times y minus b times y squared. And what we're going to do is actually we're going to look at the logistic equation, the solution. And in our previous video, we looked at a specific example, and so we're going to continue with that specific example. So what we're going to do is we're going to solve the problem we've looked at before that we've graphed, and that was y prime equals 3y minus y squared. So that's what we're going to do. And we're going to initially just give it any initial condition, say y of 0. So here we go. Let's solve this. Now, there's more than one way to solve this, but we've seen this approach before, and it's a very clever approach, I think, and so it actually has further extensions. So we're going to try that. And that was this. We're going to solve with a substitution. So we're going to let z equal 1 over y. Now, this looks simple on the surface, but remember, so let's think about what y is. So recall, y is a function of t. So this is, I'll write that, y is a function of t. The function of t. But wait a minute, I just wrote z as a function of y. I really could have written this as z is a function of y, and in this case, z is 1 over y. But wait a minute, y is a function of t. So if I really want to just detail this out, I would say that z, which is a function of y, which is a function of t, is equal to 1 over y of t. That's the substitution that we're going to make, and let's see how that helps us to solve this problem. All right, so I'm going to take the derivative of z with respect to t. Well, remember what that means. We have to apply the chain rule. So first we would take the derivative of z with respect to y by the chain rule, and then we would take the derivative of y with respect to t. And let me just show you. I think sometimes we lose track of that. But I'm just going to do a quick side note. Maybe if I have a function g of f, let's just write it this way. G of x equals the sine of x squared. Well, I could also think of this as the function of g of u of x, which is the sine of u, where u is x squared. So, but we know that to take g prime, I'm going to write out the we'll write out the whole piece of u of x. Well, what we had to do is we first take the derivative of the sine. Well, this derivative of the sine was the cosine of u, and then we take the derivative of u. Well, the derivative of u is the x squared, so that's 2x. And so our final answer was the cosine of x squared times 2x. In other words, this is the derivative of g with respect to u times the derivative of u with respect to x. And that's a little side note here. That's something that you've seen before that might be a more comfortable way of looking at how we are making the chain rule application here to z equals 1 over y. Well, the next thing we do is we use all of this work. So let's use this work. This is dz dt, that's another way of writing z prime. dz dy, that's the derivative of z with respect to y. Well, y is 1 over y, or y to the negative 1. So we apply the power rule. So this is going to give me a minus 1 over, and then y to the minus 1, we subtract another 1. So this is y to the minus 2, or y over y squared. That's dz dy times, what in the world is dy dt? dy dt is where this whole problem started. That dy dt is this, y prime. So now we make that, we substitute that in there. So if we continue, now we have times 3y minus y squared. Okay, so let's multiply this out. So now I have z prime equals minus 3 over y. And then I'm distributing this through, and then I have a minus y squared. I'll write this out. So I have a minus y squared over a minus y squared. Well, what do? We simplify this. So this becomes z prime equals minus 3. I'm going to write it this way. Oops. Minus 3 times 1 over y plus 1. There we go. I cleaned up pretty nice. But wait a minute. Recall this. Let's look back at what we were up to. 1 over y, that's z. Oh my gosh, and there it is. Now we can put this all together. So the problem that we're really solving is that z prime is equal to minus 3 times z plus 1. And what is the beauty of that? That is a first order linear differential equation. And we know how to solve that. We can solve that with our integrating factor. If we look at this as z prime plus 3z equal to 1. Well, right off the bat, we know our integrating factor m is going to be e to the positive 3t. And so when we write this, we're going to look at this. Oh, and also, yeah, I'll clarify this. So we're going to take the integral from z of t, or from z of 0 to z of t. And remember, when I write z of t, that's really the same as z of y of t. It's just a little shorter, times the derivative with respect to t of e to the 3t times z of t dt. And on the right-hand side, if we take the integrating factor times 1, I'm going to pick up the integral from 0 to t of e, and I should use a dummy variable, e to the 3s ds. Okay, we're almost done. Almost done. Well, what do? On the left-hand side, we're going to pick up an e to the 3t times z of t. And minus, we put in our initial condition, this becomes e to the 3 times 0 times z of 0. On the right-hand side, we're going to pick up a 1/3, I'm going to write this over here, 1/3 e to the 3s evaluated from 0 to t. Well, that's going to give me a 1/3 e to the 3t minus 1/3. Okay. Oh, let's remember e to the 0 is just a 1. So I can write this as e 3t, oops, e to the 3t times z of t is equal to z of 0 plus, let's do it this way, minus, I'm going to group these, minus 1/3 plus 1/3 e to the 3t. And the reason I did that is z of 0 is a number, it could be 5 or some other number, 4. And then 1/3 is a number. So let's just put our numbers together and our exponentials together. And our next step now is to multiply all of this through by the reciprocal of e to the 3t. So I'm going to multiply both sides by e to the minus 3t. Well, let's see where this puts us now. This takes us to z of t is equal to, I'm going to put parentheses, I'm going to add the z of 0 minus 1/3 e to the minus 3t plus, well, e to the 3t times e to the minus 3t. The exponential part becomes e to the 0. That just is 1. So I'm left with 1/3. Okay, I'm going to take a moment. I'm going to copy this and go to another page. If you have room on your page, you don't have to go to a new page, though. So hang on. All right, now we can continue because we're almost done. Remember this. Remember that z is 1 over y, and we also had our initial condition that of some y of 0. Well, if I plug all these back in, then this is 1 over, I'm going to think of it as this way, 1 over, I'm going to make a big step, I'll write it out, 1 over y equals 1 over z of 0 minus 1/3 e to the minus 3t plus 1/3. And now let's just flip these two fractions. Or if you wanted, you could cross multiply, or you could multiply both sides by y and then multiply by 1 over what's on the right hand side. The result is very simply y is equal to 1 over parentheses 1 over, oh, that shouldn't have been a z of 0 up above. I'm sorry. Let's go make a quick fix right now. That should be a y of 0. Okay, so 1 over y of 0 minus 1/3 e times e to the minus 3t plus 1/3. And there is your answer. Let's write it here as y of t. There's my y of t. Now, let's clean this up. That's a fraction with a whole bunch of fractions in the denominator. I'm going to multiply both the numerator and the denominator by the common denominator, which in this case is 3 times y of 0. 3 times y of 0 over 3 times y of 0. So we could say that y of t equals 3 times y of 0 over, now I'm distributing the 3y of 0. So I have to distribute it through the parentheses. So then 3 times y of 0 over y of 0 is going to leave me with a 3. Minus, then we're going to pick up 1/3 of 3y times 3 times y of 0, which is going to be y of 0. E to the minus 3t plus 1/3 of 3 times y of 0 is simply y of 0. And that is how we solve the logistic equation. And I want to close with one last point, and that is this. The logistic equation is of the family, or of the group of equations, or the group of differential equations called Bernoulli equations. Bernoulli equations. And the general form, Bernoulli equations, the general form is y prime equals a y minus b times y to some power n. And the problem we just solved, n is 2. And if you have this is solved by the substitution of z equals 1 over y to the n minus 1. And that would give you the general solution to all Bernoulli equations. I hope that helps. Thanks for watching.